Hi, in this video we're going to look at some CAS calculator tips for VCE Specialist Maths Calculus. First one is the Differential Equation Solver, deSolve or dsolve. So for a question like this, we're given a differential equation and the question is to solve it. So we can do that straight in dsolve. If I just find we'll do it on the TI-nspire first. And menu, calculus. We've got to scroll down to differential equation solver. Okay, so we type it in dxdt, we're going to type in as x dash plus x divided by 20 plus t. It's not really, you can't use the fraction template in here. We could inside the calculator page, and I'll show that in a minute, but for now, so it's x dash plus x over 20 plus t equals 0. The independent variable here is t, okay, because we've got dx dt, so the dependent variable is x. And condition is our boundary condition or initial condition. And we do have one here. It says a tank initially has 20 kilograms of salt, and x is our kilograms of salt. So x of 0 is equal to 20. So meaning that when t is 0, x is equal to 20. We only need one condition for this because it's a first order differential equation. So that should do it. Click OK. And so this is the syntax. So we could actually use the fraction template within here if we wanted to change anything. But let's press enter and there we are. That's our solution. We get a little warning which says about the domain. T plus 20, it's probably going to be fine here because t is going to be positive only, so we would never get in singularity there. So that's our dsolve. Let's show it on the Casio Classpad now. Same sort of thing, interactive, where are we? Advanced and dsolve. We do want to include a condition, so same sort of thing, x dash plus 20 plus x over bracket 20 plus t equals 0. Independent variable t, dependent variable x, and position x of 0 is equal to 20. Boom, there we go. So actually get a modulus sign in here. Again, in this case, you probably don't need to worry because t is always going to be strictly greater than 0. But there we are. So that's the differential equation solver. Funny thing, this is actually a 3-mark question, but it's exam 2, so we can use the dsolver. Probably just need to state clearly the differential equation, probably the initial condition, and then, yeah, solve it. 3 marks. You know, because it's a CAS exam, so we are allowed to use the functionality of the CAS calculator, which does include the dsolver. Let's have a look at another example. This one is a kinematics example. A particle moves in a straight line. At time t seconds, its displacement is given by this equation. So v is dx dt, right? So we can do this using the differential equation solver. We're looking to find an equation for t. So we might just do this one on the ti. I might just copy what I've got from here. So to show you how to enter it in like this, you know, we can use fraction template or anything in here. Probably don't need to for this one. V is dx dt, so that's going to be x dash is equal to 9 plus x squared. And the syntax is and the initial condition. So the condition here, initially x is 3. So when t is 0, x of 0 should be equal to 3. Other than that, it's the same as the previous one. Independent variable is t, dependent variable is x. Oh, non-real result. Because I got a y in there. Where did that y come from? Not y, should be 9 plus x squared. That's a boom. That's a boom. So arctan is inverse tan, x over 3 minus pi on 12. There we go. So dsolver, make sure you know how to use that one. Next one is going to be, this is a little bit of a CAS hack, and it's just for evaluating definite integrals. if you've done some practice exams already, you notice pretty much every year there's a question like this, which is an integral, which is asking us to do a u substitution so we could evaluate it. But the thing is, like, this is a definite integral, right? So this has a numeric value. And we can actually calculate that numeric value using the CAS calculator. And, well, which one of these is equivalent to this definite integral is just the one that has the same numeric value. So all we need to find is the one, again, we can evaluate that on the CAS, and that's really a gimme mark if you know how to use your CAS. So we'll just evaluate this integral on the CAS. So menu calculus integral, or shift plus, pi on 12 to pi on 6. So the only thing that takes a while is probably typing it in. But, you know, the more you practice, the quicker you get. You can type pi for pi, but if you're on your handheld, it's probably easiest just to use the button. Cos 2x over sine squared 2x. Now we've got to type sine squared as sine 2x brackets squared. That's okay. And we want a control enter to get a decimal here. So 0.42 something. And then we just need to try each of these. Which ones to try first? Well, you probably, if you know anything about u substitutions, you probably know that if we make a substitution, it's likely that the terminal is going to change. So my substitution here might be, for example, u equals sine 2x. Or maybe it's going to be u equals sine x. Whatever it is, once we sub in x equals pi on 12, the u value is going to be something different. So I'm probably not going to try those two options. I'm going to try one of these. And you can see they're all pretty much, well, they're quite similar. This has got a u squared instead of 1 on u squared. So let's just start with option A. Half to root 3 on 2. And it's 1 on u squared. So I'll just do that as u to the power of -2. Du, and again, control enter, and I'm getting 0.84. Oh, so I forgot my half out the front. Well, actually, what we're looking for is 0.422. And when I don't halve it, I get 0.84. So I think if I do halve it, I should be looking pretty good. There we go, 0.422. So we sort of got lucky that A was the correct option there. But yeah, I mean, like I said, you're likely to try these ones first, where the terminal changes, and then you've only got a few to try. So with that little CAS hack, this is a gimme question. It just takes a little bit of time to type it in, but at least you can be sure that you've got the correct answer. And the last one we'll talk about is using the matrix notation for vector calculus. And this can be quite powerful on the CAS calculator. So if we've got a question about a position vector, it's got a vector function in terms of I and j. We want to find the first time when the speed of the particle is a minimum. So we first need to know, like, what is the speed? The speed is the magnitude of the velocity, and the velocity is the derivative. So we want to differentiate this function. And this one is probably not too hard to do it by hand anyway, but let's just show how we would do it on the CAS calculator. And we can do it as a matrix. So for vectors, we can either do them as a column matrix or a row matrix. I like doing it as a row matrix because I can just type in like something, comma, things separated by commas, and the CAS will read that as a row matrix. So it's quite quick to type in. So in this one, my function is 3 cos t I 4 sin t j. So 3 cos t, comma 4 sin t. And that's our function. We want to differentiate that. So menu calculus derivative, or shift minus. And we want to take a derivative with respect to t. And there we go. So again, like, yeah, you could have done that by hand, but now the speed is going to be the magnitude of this function. The magnitude, in terms of matrix notation, is the norm function. So we go menu, matrix and vector, and norm. Okay, so the norm is the magnitude. We want to take the norm of this, and that would do it for us. Okay, so again, you could do square root this one squared plus this one squared, but that's just a bit quicker. You know, you can also just type in norm for norm. Okay, so that's the speed function. And now we just need to find the first time when that speed is a minimum. So how would we find when this is a minimum? You could graph it, look for the local minimum, but we can also use the fmin function. So that's under calculus, function minimum, or again, you just type fmin. Copy this function down, and comma t we need, because t is our variable. In this case, it's going to have a lot of local minimums, or a lot of absolute minimums, because it's a trig function. We want the first one, so we can do a domain here, and it's just like comma, lower bound, comma, upper bound. So comma, 0, say, we don't know. We don't know where it is, but let's just say we go between 0 and 10, and that'll give us all the local minimums between 0 and 10. We want the first one, so that's when t is equal to pi on 2. Okay, so there we go. I'll show the same one on the Casio Classpad. I mean, everything's pretty similar. Again, we can use that notation of just typing it in and using a comma. So was it 4 cos t? No, I can't remember. 3 cos t, 4 sin t. We want to take the derivative of that with respect to t. And then we want to take the absolute value with the norm function. Fmin is quite good on the Classpad because fmin would actually give you not only the... Oh, undefined. That's not good. Maybe I'll need a domain there. So let's say between 0 and 10. Why am I getting different answers? Getting 0, pi, 2 pi. Okay, it's because I typed in my function wrong. So it was supposed to be 3 cos t, 4 sin t. So, I'll do it again. Taking a derivative, we want to do the norm of that. And then fmin within our domain 0 to 10. And there we are. So it's given us the t values, and it's also given us the y value. Where in this case, that would be the actual minimum speed. This question didn't ask for it, but that's quite nice on the Classpad that it would actually give you the t value and the y value, or the speed. Okay, hope you find those CAS tips useful. There's a thumbs up button you can use if you did. See ya!